Hello, Algebra 2A folks. We are going to do a lesson today. This is the start, the beginning of topic 3, which is on exponential functions. So the learning target for today, I can identify and write equations for exponential functions. One thing that maybe you've heard of in the past, maybe in a different math class, is in math something called a function, and some people think of, they call it like a function machine, and there's usually some sort of rule to this machine. So you input your x value, and then maybe the function is let's add 5, or let's divide by 3, or let's subtract 6, or something like that. There's some sort of rule, and then there's an output. Now, this picture I have is fancy notation. We'll see this in a little bit. This you would say this as f of x. It's called function notation, and it's just really a fancy way of saying y. So generally you input x, there's some rule, you do something with the x value, and you output a y value. That's the typical idea of a function in math. So we're going to do something called exponential functions. Well, we have a story here to warm up about Lauren. It says Lauren is raising rabbits. She keeps track of how many rabbits she has versus how many months since she started counting in March. The data is shown in the table. So I'm going to scoot down here a little bit. But you can see that in March, we've got 24 rabbits, April there's 48, etc. Our first question is, what is the pattern for the number of rabbits from month to month? And then follow-up question, if the pattern in the number of rabbits continues, how many rabbits will there be in December? I know there is a question number 3 here, but I'm going to pause for just a moment. So, and I encourage you, pause the video if you can, if you want, and see if you can spot a pattern in the number of rabbits. 24, 48, 96, 192. So thinking about how might you go from 24 to 48, what kind of things could you do starting with the 24, do something to get a 48, start with a 48, do something to get 96, start with 96 to get 192. So again, if you haven't paused it, give you a chance here. But what I see, if I think about addition, I'm not adding the same thing every time. First it would be plus 24, then plus 48, then plus 96. You might say that's a pattern that you're going to add the number that there is, but really the pattern is that we are doubling. Maybe a quicker way to say it is we're just multiplying by 2, we're doubling. All right, so there it is in writing. Multiply by 2 or double. 24 times 2 would give you 48. 48 times 2 would give you 96. 96 times 2 would give you 192. Now, how would we get that if we were thinking about multiplication? And I forgot to box in my answer, but there we go. Multiply by 2 or double is the pattern that I see. How would we figure that out? If we're thinking to ourselves multiplication, I could say, well, what if I start with 24, I multiply by some number, call it x, and I get 48? Or what if I start with 48? I multiply by some number, I'll call it y, in case it's different than x. Start with 48, multiply by some number y, and I get 96. I start with 96 and I multiply by some number. I'll use a different variable here in case it's a different value than x or y, and I get 192. Well, all 3 of these equations, if you solve them, your variable value is 2. All variables will equal 2. And so that's how, instead of just, guessing and checking, all variable values equal to is what I meant to say. There we go. All variables will equal to. You divide by 24. 48 divided by 24 is 2. 48y equals 96. Divide by 48. 96 divided by 48 is 2. 192, you would divide by 96. You'll get 2. So that's how you could figure it out without guessing and checking. You could say, let's look at the multiplication, let's set up an equation, and then let's solve our equation. Okay. So that's number 1. And then, if you haven't had time to think about number 2, it says if the pattern in the number of rabbits continues, how many rabbits will there be in December? So again, if you haven't, I encourage you to pause the video, think about that. And if you need a hint, I'll give you something here. So if we kind of set up maybe a table or some columns, if we just continue this pattern of doubling, from June we got 192 rabbits, and then we could say, well, how many in July, how many in August, etc., until we get to December. So again, if you need, you can pause the video. I'm actually not going to write down answers for the other months because I'm going to work what I think is going to be a little bit smarter instead of harder. But I know that I would multiply by 2, 192 multiplied by 2 to give me July's number. Then whatever number that is, multiply that by 2 to give me August, and then whatever number that is times 2 for September. And I'm just going to keep continuing this pattern of doubling, multiplying by 2. And so I'm going to go to the calculator with something a little bit different here. So December's number, if you notice that repeated multiplication by 2, and some of you might remember if you took Algebra 1A, we do things like this. Repeated multiplication can be represented with an exponent. So I'm multiplying by 2, let's see, overall once, twice, 3, 4, 5, 6 times. So I could say it's 192 times 2 to the 6th power. And so I can go to the calculator. If I know how to do an exponent on the calculator, I can put that in the calculator. And I'll show you here in just a moment how to do that on the calculator. So on my calculators, my classroom set, at least the calculators I have at the time of this video recording, I'm going to start with 192. I'm going to ask my calculator to multiply. And then to do 2 to the 6th power, I'll do 2. And then my calculators have this button that looks like y to the power of x. That's the exponent button. And then I'll put in the exponent of 6, and then I'll press the equals. Okay. So if you're using my calculators, see if you can do that sequence, 192 multiplied by 2, y to the power of x with a 6. See what that comes out with. A lot of other calculators, you might have this button instead of the exponent button. That's called a caret, technically. Depending on your calculator, it might look a little bit different. But see if you can figure that out. I mean, you could always just say 192 times 2 times 2 times 2 times 2 times 2, all those 2s, and then just press equals. But if you want to work a little smarter instead of harder. But turns out this comes out to, according to my notes at least, 12,288. And that is, we're talking rabbits in this if you go back to the story. 12,288 rabbits in December, if this pattern continues. Now, what's happening here? Okay, over 12,000 rabbits might seem like a lot. When we started with 24 in March, from March to December, that's what, 9 or 10 months, and we went from 24 to over 12,000. But I'm just going to scroll back up here real quick. This example, what we did there with the exponent, is an example of an exponential function. If you notice the word exponent is in the word exponential, they're related. And exponential growth happens or can happen very, very quickly. You can quickly go from 24 to over 12,000 in just, in this case, a matter of months. Okay. In the real world, of course, things might happen. The pattern might not continue with the rabbits, but we're pretending that the pattern continues. Okay. All right, so let's look at number 3. Still talking about these rabbits. Number 3 asks us if m is the number of months since March and r is the number of rabbits, write an equation to represent the table from number 1 and 2. So we're defining variables here. M is the number of months since March. R is the number of rabbits. That's defining the variables. Okay. But again, yeah, as usual, I recommend pause the video, see what you can do with this. I'll give you just a moment here. I'm gonna set up a table. So here's the table that I'm going to use. I filled in the months. I filled in the number of rabbits, which we're using R as the variable. M might be a little tricky, but see if you can come up with the values for M, which again, M represents the number of months since March. And then to help me come up with the equation, I'm going to look at the work. So again, if you haven't paused the video and had a chance to think about it, take some time there. So the values for M, the number of months since March, March itself might be a little tricky. But April is 1 month since March. May is 2 months since March. June is 3 months since March. So if you follow this backwards, June, May, April, March, we're going 3, 2, 1. This would be 0. March is 0 months since March. March is 0 months since itself. So we could use 0 as the M value there. The work we could do, again, I'm going to come back to March for the work. But let's see, in April, what did we do? We took, or we said we could take the 24 rabbits from March and we could double, multiply by 2. So that's the work that I could do to get that 48. Now, May, you could say that we could take the 48 rabbits from April and double it. But what I'm going to do is I'm going to keep the 24. So I would have, let me switch my colors here. I would have, this would be April's number. But then I would double that number. So that would get doubled. And you could double check that. 24 times 2 times 2 will give you 96. And then for June, again, I could say 96 times 2. But what I'm going to do here is I'm going to say, let's take Let's take the expression here, because that's an expression for May, 24 times 2 times 2, and let's double that amount. So it's kind of looking like what I did in number 2, where I said, you know what, I'm not actually going to figure out July and August. I'm just going to keep multiplying by 2 till I get to December. So if I write this with exponents, April might be a little bit difficult, but in May we have a pair of 2's. So we could say that's 24 times 2 to the second power. In June, we have the base, what's called the base of 2, 3 times. So we could say 24 times 2 to the third power. Even here with April, we could say, wow, there's a single 2. We could say it's 24 times 2 to the first power. Since the other 2's have exponents, what if we want to give that 2 an exponent? It's 2 to the first power. So pause it there. See if you can spot anything. See if you can generalize to say, what if we just generally wanted an expression for R? If I was going to tell you, 12 months since March, or 15 months, or 20 months since March, M is 20, could you come up with a way to calculate R? So pause the video if you haven't there. But what I notice is that the months since March and the exponent match. So 1 month since March, exponent is 1. 24 times 2 with an exponent of 1. 2 months since March, 24 times 2 with an exponent of 2. 3 months since March, 24 times 2 to the power of 3. That's not a coincidence. So I could say, generally, to get the number of rabbits, take the 24 you start with and multiply by 2 as many times, an exponent of m, as many months since you have gone since March. That's my equation. And you can check that that's going to work for April, May, June. Even March itself, if you use an exponent of 0, you could say this is 24 times 2 to the power of 0. Check it out on the calculator if you want to. Some of you might remember that when you have something to the power of 0, it's not 0. The value is not 0. A lot of people think it is. It's 1. So this is 24 times 1, which is 24. And that's how many rabbits we got there. So there's your equation. I have one more note before we move on here. I'll make a note about the months. The value of m matches the exponent. Okay, so there you go. Notice that the value of m matches the exponent. And then one other thing here. I boxed in this answer. R equals 24 times 2 to the power of m. Please be aware of a very common mistake. So a common mistake, students go, oh, well, 24 times 2 is 48. So 48 to the power of m. I go, no, it's not. It's not 48 to the power of m. Think about order of operations. GMA, I got the poster of GMA up in my classroom. Some people do PEMDAS. But generally we do our exponent before we multiply. So we're supposed to do 2 to the power of m first, and then whatever that result is, 24 times that result. Okay, so order of operations, exponents before we multiply. Since I can't perform 2 to the power of m, I don't do anything. I'm like, I'm done. 24 times 2 to the power of m. That's it. We're done. Okay, and again, you can check that against your values of m in the table. You can even check it against December. What would December be? Let's see, April, May, June, July, August, September, October, November, December. If you do 24, I'll do it on the calculator real quick. 9 months since March is December. We got an answer on number 2. If I do 24 multiplied by 2 to the power of 9, I should get that 12,288. Boom, there you go. So that equation seems pretty good. All right, let's keep going here. So some blanks to fill in. Generally, what are exponential equations, or we can also sometimes call them functions. I think in the learning target, we call them functions. Equations or functions. Generally, exponential equations, the equation looks like y equals a times b to the power of x. Okay, that's just generally how they look. Or if you remember, I'm going to scoot up real quick here. If with the function machine, this f of x, this thing called function notation, it's basically just the same thing as y. The whole thing. It's not f times x. It's a function of x. I understand if you think it's multiplication, but it's not. But so sometimes people will write f of x equals a times b to the x. But yeah, that's it. Just this f of x thing, this weird looking notation, is just that whole thing is a stand-in for y. Okay. So that's what the equations look like. We had that kind of, we had R and M in number 3, but you could imagine if that was y equals 24 times 2 to the power of x. That kind of looks like that down there. So here's what the things in the equation represent. You might say A represents the initial value, the starting value, the starting amount. That'd be if you have a story. And that's what we had for our story with the rabbits. We were starting with 24 rabbits, and it was 24 for A, 24 times 2 to the power of x. We started with 24 rabbits. That's not a coincidence that we had 24 as that first number. A is the first number typically in the equation. We had 24. That's what we started with. But what if there's not a story? What does A represent then? If there is no story, if we took away the months and that these were rabbits, and we're just like, hey, I got a table of values, 0 and 24, 1 and 48, 2 and 96, 3 and 192, then we might say that A is the y-intercept table graph. And we won't do it today, but we'll do it another time. We will create graphs for these equations. We'll graph the points from a table, and we'll see that, hey, the graph for this, I'll just kind of sketch it here real quick. The graph for this would look like, whoops, that's a very rough sketch. It would kind of look like this. Remember, those rabbits are going to increase really quick. But this point right here, that would be the 24. All right, if we were to graph it, that point where we cross the y-axis. Okay. And what about B? What does B represent? Well, B is often called the common multiplier. It's what we keep multiplying by. So in the story, that was a 2. B has the exponent, and if you notice in our equation from number 3, the 2 had the exponent. We said, well, that was the pattern. We keep multiplying by 2, so that's your B value in that example there. Okay. One more thing I'll say before we move to the next page. I call B the common multiplier. Some people call B the common ratio, and we'll see why here in a moment. I'll explain why it's called the common ratio in a moment. But yeah, so hopefully that's helping so far. We got some more examples on the next page. Let's take a look. So just a reminder here that exponents generally represent repeated multiplication. There you go. Exponents represent repeated multiplication. That's why I'm going to go back up real quick here. Back here in number 2, and instead of actually typing out times 2 times 2 times 2, I could use an exponent as a shortcut there. Same thing with my equation in number 3. I'm going to keep multiplying by 2. How many times? Well, how many months? As many months as it's been since March. That's how many times I'll multiply by 2. So I can use an exponent to represent that repeated multiplication. Okay. All right, so let's practice a little bit more, kind of like with number 3, writing the equations here. But now we don't have a story. So I'll take you through here. Again, I encourage you to pause if you want to try this, but I'll break it down for you here. Basically, what we need a value for A and we need a value for B. To write the equation, we need to find values for A and B. Because if you remember what the equation looks like, generally, it's y equals A times B to the power of x. So yeah, if you can figure out what number you got for A, if you can figure out what number you got for B, you just put them in. X is going to stay as an X in the equation, Y is going to stay as a Y. So what I'm actually going to do first is I'm actually going to start with the B value. That's what I'm going to do first. I'm going to look for, B is the common multiplier, the common ratio. So the B value, well, let's see here. One thing we'll write down underneath, but notice how X plays nice. We're going from 0 to 1, 1 to 2, 2 to 3. I call that playing nice. We want to make sure that's happening before we try to write the equation. I'm not going to trick you, or I'm not going to try to trick you, except maybe as extra credit, but make sure your X values play nice. But I say, all right, what happens if we go from 5 to 20? And I say, all right, 5 times B equals 20. What am I multiplying by? You might know this already. I hope you have the number sense. But if the numbers are more difficult, this is the process. You can say, I'm going to start with that first y value of 5, multiply by something b, and I get 20 as a result. If you solve that equation, divide by 5, we get a b value of 4. Hey, all right, find values for a and b. I just got the b value for number 4 there. Okay. You can double check to make sure, 20 times 4 is 80, 80 times 4 is 320, but I've got the b value, it's 4. Okay. So now what I have to do If you remember all the things we had as choices in with our systems of equations, we have a choice to make here. There's many choices that are correct. We have to choose now one of those pairs of x and y values. So we have the b value. Now we need the a value. You come up with the a value, and we can write the equation here. So we have to choose an xy pair. I'm going to choose, just because my cheat sheet says this, I'm going to choose 2 and 80. So if we use 280, and don't worry, I'm going to check this, but so here's what that looks like. So I've got my equation, my general equation, y equals a times b to the power of x. All right, well, let's see here. I'm going to temporarily use a y value of 80. That was my choice. If someone else decided they wanted to use 3 and 320, they'd use a y value of 320. Someone else said, I want to use 1 for x, 20 for y, they'd put in a 20 here. Or you want to use 0 for x, 5 for y, they'd put in a 5. But I'm choosing 80 for my y value. I'm choosing that 2 and the 80. All right, so following the equation, this is equal to, I don't know the a value. That's what I'm figuring out, so I'll leave that as a variable. My b value, oh, hey, we figured that out up above. B is 4. And then the x value, I'm going to temporarily use an x value of 2. I decided. All right, so kind of like with systems. Remember, systems, we had 2 variables, and we would do something to get 1 variable. Well, I went from 4 variables. Y equals a times b to the power of x. That's 4 variables. And now I have an equation, and there's only 1 variable. That's huge. So now I'm going to solve this for a. So I can simplify on the right side. I can do 4 to the second power. So 80 is just going to hang out and wait. 4 to the second power, you might recognize that as 4 times 4. If you want to use the calculator, for exponent button with a 2, but that's going to be 16. Remember, it's not 4 times 2. It's not 8. I have enough ways to write 4 times 2. It's 4 times 4. Or just let the calculator do it for you then. Okay? I'll divide this by 16 to cancel that. Divide that by 16, and I get 5 equals a. All right, so I've got it now. I got my b value, I got my a value. So let me write out my answer. Let me write out the equation here. Put it all together. So the equation, y and x are going to change back to variables. And I'll explain why here in a moment. But I got y equals, my a value is 5, my b value is 4, and that's raised to the power of x. That's my equation. So I'll pause for a moment, or you can pause and give yourself a chance to catch up there. But I'm going to check this on the calculator. If I was live in person, I would probably do a little bit of this writing down, but I'm going to show you on the calculator here. I'm going to try every single one. I'm going to try every single one of these pairs of values. And basically all I have to do is I'm going to do 5 times 4 to the power of x. So if I start with 5 times 4 to the power of 0, I should get the y value of 5. Boom, got it. If I do 5 times 4 to the power of 1, if I use an x value of 1, I should get a y value of 20. Y equals all this stuff, I should get 20. Boom. 5 times 4 to the power of 2 should give me an 80. Got it. And then 5 times 4 to the power of 3 should give me 320. Oh, got it. So I really, really like that equation. Y equals 5 times 4 to the power of x. Okay. All right, pause it there if you need. When you're ready, though, try out number 5. See what you can do. Same process, just different numbers. Start with your b value. Find what b equals. What do you keep multiplying by? And then after you get your b value, choose one of the xy pairs and find your a value. Sorry, I did forget to mention too, make sure your x values are playing nice. So x is going from -1 to 0, then 0 to 1, then 0 to 2. I go, that's pretty nice. Counting by ones, that's nice for x. But let's see, for the b value, if I go from 0.02 and I multiply by b, I'm supposed to get 0.2. Well, I can solve that. I'll divide by this 0.02. And then divide that over there and grab the calculator if you need to, but I'm pretty sure that one is 10. And I can double check that. 0.2 times 10 will give me 2. 2 times 10 will give me 20. So B is 10. All right. Now I need the A value. And remember, this is where you get to pick one of those pairs. On my cheat sheet, what did I go with here? My cheat sheet, I did the -1 and the 0.02. So I'm living dangerously here. If we use -1, 0.02, that's my x and my y value. So I can put in for y, let's see, for my y value, I chose to use 0.02. Again, somebody else might have chosen 20 or 2 or 0.2. I picked 0.02. But then filling into the equation, that's equal to the a value, which I don't know, but I'm figuring out, multiplied by the b value, which is 10, raised to the power of x. And if I'm using 0.02 for y, I have to use -1 for my x value. Okay. So again, went from 4 variables to 1 variable. That's good news, because I think I can probably solve for that 1 variable. Let's see what it looks like here. We can do the exponent. We can do 10 to the -1st power. Put that into the calculator if you need to. It's tough. Negative exponents can be tricky if you're not sure, but that is going to be 0.1. And then I can divide by that 0.1. And that'll give me my a value. So I believe that is that 20? Oh boy, I should use the calculator. Oh, 0.2. 0.2 is what I get there. But I'm going to check this. So that's my a value. So if I put this into my equation now, change x and y back to variables. So y equals a, I believe, is 0.2 multiplied by the b value, which is 10 to the power of x. So before I box this in, I think I'll check it real quick on the calculator. So basically, if I do 0.2 times 10 to the power of a one that's negative, I should get 0.02. Got it. Okay, if I do 0.2 times 10 to the power of 0, I should get 0.2. Boom, got it. If I do 0.2 times 10 to the power of 1, I should get 2. Boom, that's my y value. That's what I'm supposed to be getting. And then if I do 0.2 times 10 to the power of 2, we should be getting the y value of 20. Boom, got it. So I like that equation. Let's box that in now. Okay, so again, don't forget you can check on the calculator. Maybe I'll type one out here real quick. We'll just do an example. There you go. So there's one in writing. So if we use the x value of 2, then according to my equation, y equals 0.2 times 10 to the power of x. And when I did that in the on the calculator, it gave me 20. And I go, yeah, that's what y is supposed to equal if x equals 2. So it feels good. I did it with all of the pairs of values on the calculator, but there's one in writing. Okay. All right, let's finish up here. We got a few blanks to fill in, I believe, and then let's talk about identifying. I'm going to jump back up real quick, but we've done the writing equations now. So we got that from our learning target, and of course we need more practice. But what about the identifying? Let's work on identifying those exponential functions. So here we go. The last couple problems, a few blanks to fill in. So it says here, for a relation to be an exponential function, we can look for 2 things in a table. One thing we can look for is if x plays nice, and I mentioned that means x shows a pattern of adding. So we want x to play nice, which means x is adding the same number. It's usually going to be adding 1, but technically it doesn't have to be adding 1. It's just that makes it a lot easier for the equation, coming up with the equation. And like I said, I'm not going to try to trick you on the test, except maybe as extra credit. Maybe x won't play nice for extra credit on the test. And we'll see if you can figure out the equation or whether or not it's exponential. So, all right, to be exponential, we want x to play nice. And then y needs to show a pattern of multiplying, that repeated multiplication. That's the exponential part. So we want y to show a pattern of multiplying by the same number. And that's b in our equation. Y equals a times b to the x. That's b. That's how we know for the equation. Okay. So a couple more problems. Whoops. And I think that I changed things up from last time I did this. So this is a typo here. Maybe before you get this, I don't know if I printed this yet, but this should say for 6 and 7, tell if the relation is an exponential function, explain. So all we have to look for, 2 things, we got them up here. Does x play nice? Does x have a pattern of adding? If it does y show a pattern of multiplying? by the same number. That's all we have to do. We don't need the equations for 6 and 7. So make sure you're reading carefully. It's a common mistake. I get a lot of students on the quiz, on the test. If you look real quick, I don't know if I can zoom out here, but what we're given for number 4 and 5, we have a table on number 4. We have ordered pairs, a set of ordered pairs on number 5. Hey, 6 and 7 look very similar. Number 6, we have a bunch of ordered pairs, x and y values. Number 7, we have a table. These look the same. But notice the directions. The directions are different. 4 and 5, I was supposed to come up with the equation, write the equation. But 6 and 7, all I'm doing is tell if the relation is exponential. That's yes or no. That's it. So read carefully. But here we go. So make sure x plays nice. What's x doing here? So x is going 0 to 1, 1 to 2, 2 to 3. We're adding 1. So x plays nice. Whoops, I'm going to write that a little bit lower. X plays nice, we got it. Quote unquote plays nice. All right, so then we want to see if there's a pattern of multiplying with the y values. So let's take a look at that. So we go from a y value of 3 to a y value of 6. So I can say, all right, 3 times b equals 6. Again, you might already know that b is 2, but this is the process. Solve that equation, you get b equals 2. All right. Now that doesn't mean that it's exponential, not in itself. I need to keep multiplying by 2 for this to be exponential. And again, you might already see that, nope, this does not work out. But let's try it. What if we did 6, the next y value, 6 times b equals 9? Well, you might already know it's not 6 times 2 to give you 9. Last time it was 3 times 2 to give you 6. 6 times 2 is not 9. But if I just go through the process, this is going to give me 1.5. So I can stop here. I don't have to keep going and say, well, wait a minute, what about from 9 to 12? I mean, I could check that. But already I have different b values. So there's not a common multiplier. By the way, it's called a ratio. I think I said I was going to mention that. It's called a ratio because something like this is often, a fraction is often known as a ratio. So if you're wondering why b is called a common ratio. But I'm not multiplying by the same thing. First I multiply by 2, then I multiply by 1.5. I don't even care what I multiply by from 9 to 12. There's no common multiplier. We're not multiplying by the same number. So number 6, not exponential. Okay, so that's my final answer. So I erased my circle around the b values so people don't get confused and think that's my answer. My answer is this relation is not exponential. There's no common multiplier for the y values. All right, what about 7? If you haven't had a chance, pause the video, see if you can figure out number 7. Okay, same thing though. First, make sure x plays nice. All right, what happens with x? 0, 1, 1, 2, 2, 3. Yeah, x plays nice. So then let's see, x plays nice. Let's see if we have a pattern of multiplying in the y values. So first we go from 5 to 35. So again, you might already know, oh, I know what I multiply by. But this is the process. If you don't know the numbers are more difficult. 5 times b, 5 times something equals 35. Solve your equation. You get b equals 7. All right, but does that stay? So I can do the next pair of y values. All right, how about from 35 to 245? So 35 times something, I'll call it b again, equals 245. I'll solve that equation. Divide by 35, divide by 35. And I think this one comes out to 7. Let's try it though. 245 divided by 35 is 7. All right, cool. So b equals 7. Now, I have one more pair of y values though I have to check. I can't stop here and say it's exponential. Number 6, I could stop because I go, well, the first 2 b values were different. Doesn't matter what the third b value is. First 2 are different. It's not common. So we got one more pair to check out here. So let's see. What if we go from 245? I'm getting a little squished here. 245 multiplied by something gives us 1,715. Well, solve your equation. That one, I don't know. I don't know the last 2 off the top of my head. But I'm going to reach for the calculator. So I'm going to go to the calculator with 1,715 divided by 245. 1,715 divided by 245. And I got 7. All right, so there we go. This is exponential because x plays nice, first of all, and second, we have a common multiplier of 7. All right, so there you go. I wrote out my answer. Gave a little more explanation that it is exponential because of the common multiplier. But that's it. That's done. Remember, read the instructions 6 and 7. I didn't have to come up with the equation. I could come up with the equation for number 7, but that's not what I'm asked. 4 and 5, come up with the equation. We were told 4 and 5 were exponential. Come up with the equation. So hope that video was helpful for you. Until next time, stay safe, stay healthy, and practice math.